Welcome, everyone. Thanks for joining us for another webinar session in the Change for Climate Lunchbox series. Today's session is going to focus on flood prevention at home. My name is Heather Wheelaker, and I'm here with my colleague, Karen Young. Both of us work in the Economic and Environmental Sustainability branch with the city. And we're joined by another colleague from our same unit, Cincy Modale, who will be introducing today's topic, as well as introducing our guest presenter from EPCOR. Our two presenters are Abdul Khan and Roland Newman. So just to note that this session will be recorded, and we're only recording the speaking and presentation slides. At this time, I wish to acknowledge that we are on the traditional land of Treaty 6 territory. We do this to create awareness and to remind ourselves that we are all treaty members, no matter where we are from or what language we speak. As long as we're on this land, we are treaty members. I did not grow up on Treaty 6 territory, but I have a strong sense of belonging because of the welcoming environment created here. And each of us shares responsibility to maintain and grow a respectful and inclusive community. So with that, it's my pleasure to introduce today's session. Cincy Modale is a senior environmental engineer at the City of Edmonton who works to integrate our latest information about climate change into city policy and design, and to ensure that city facilities and infrastructure and services are updated and renovated to reflect the climate changes that we can expect here in Edmonton. In short, Cincy works on climate adaptation policy and programs. And Cincy will introduce Abdul and Roland shortly. So now please join me in welcoming my colleague, Cincy Modale.
Thank you, Heather. I'll now share my screen. Welcome everyone to this session on climate change and flooding. I will provide a brief overview of the climate science and projections for Edmonton and what the city is doing about it. Following that, Abdul and Roland from EPCOR will present on the EPCOR Flood Prevention Program. I will start off by talking a little bit about climate science and modeling. Climate modeling is fairly complex, but essentially we took 12 global climate models, downscaled them for the Edmonton region, and future projections for climate were derived from that information. For an in-depth look at the climate projections for Edmonton, I will encourage you to watch the video recording from the first Lunchbox session from this series, Climate Change 101. In the next few minutes, I will share some of the climate projections for Edmonton, focusing on rainfall. As the Edmonton climate becomes warmer in the future, the climate models are projecting changes in precipitation into the 2050s and 2080s timeframe. As you can see from the graph, we are expecting a small increase in average annual precipitation for Edmonton in the form of rain and snow. Although the percentage increase in total precipitation is small, the projection is for more intense storm events rain season. The climate modeling suggests that EPCOR will experience drier summers, wetter winters, and rainfall events of higher intensity. As you can see in the infographic, both the maximum one-day precipitation and the maximum five-day precipitation are increasing, indicating that the maximum amounts of precipitation received at one time are likely to increase. This is likely to lead to an increase in urban flooding events. As the average temperature rises in the future, this leads to atmospheric conditions that are more conducive to extreme weather events. The projections indicate that the likelihood of extreme weather events, such as high winds and lightning, is on the rise. And studies show that the likelihood of urban flooding events occurring will almost double by the 2050s. This figure shows the insured losses from catastrophic weather-related disasters in Canada over the last few years. Moreover, 6 of the 10 costliest natural disasters in Canada's history have hit Alberta, the most expensive being the Fort McMurray wildfire, which cost nearly $4 billion. The hailstorm that hit Calgary last June is estimated to cost $1.2 billion in insured losses. Now that we know about the potential impacts of climate change, Let's talk about the two strategies that the City of Edmonton has developed to address climate change. One is Edmonton's energy transition strategy, which focuses on mitigating climate by reducing greenhouse gas emissions and increasing the use of renewable energy. It also seeks nature-based solutions to capture carbon. Just over a week ago, an updated version of the 2015 strategy was approved by City Council that accelerates our efforts to mitigate climate change, to cap the Earth's warming to no more than a 1.5-degree rise in line with the Paris Agreement. The other climate strategy is Climate Resilient Edmonton, Adaptation Strategy and Action Plan, officially endorsed by City Council in November of 2020, which sets us on a path to adjust our decisions, infrastructure, and services in response to the climate that is already changing and will continue to do so as temperatures rise. Today's session aligns more with climate adaptation. Climate Resilient Edmonton Strategy and Action Plan defines 5 pathways to adapt to climate change. Today's session will focus primarily on Pathway 3, preparing for changing precipitation, and Pathway 4, preparing for changing weather extremes. There are a number of actions the city is taking to adapt to a changing climate, many of which involve what we call mainstreaming, or incorporating climate change adaptation into existing policies and programs. For example, we're partnering with Fr4 on the Stormwater Integrated Resource Plan, which includes a $1.9 billion capital investment over 20 years to reduce the risk of overland flooding. We're also working with our asset management partners on how to make city buildings more resilient to climate change with the use of climate risk assessments. But at today's session, my co-presenters from Fr4 are going to focus on protecting your home from flooding. You have a good understanding that heavy rains will cause flood conditions. So rather than wait for this to happen, it is far better to prepare in advance. You can find out more information about the climate strategies on the city's website at edmonton.ca/climate resilience. It is my pleasure now to introduce Abdul and Roland from Fr4, who will be presenting next. Abdul Khan is a professional engineer with over 30 years of experience in the water and wastewater industry in both public and consulting sectors. He is part of the flood prevention team at Fr4, and the team is working towards developing and implementing an enhanced flood prevention program to assist the customers in mitigating flood risks and adapt to climate change. Roland Newman is a certified professional technologist and has extensive industry experience. He has been providing property flood risk assessments for over 10 years and has been instrumental in planning, developing, and implementing the various programs and initiatives under the industry-recognized Fr4's flood prevention program. Welcome.
So thank you very much again. And our theme for this presentation is that how we work together for a flood resilient future. So I'll focus mostly on flood prevention program. The agenda for my presentation, the agenda would be, I will quickly go through the agenda. I'll quickly talk about the city flood risk framework. The SERP is Stormwater Integrated Resource Plan, the flood mitigation options, what causes property level flooding, potential flooding risks, how do we reduce the risk, and what is our program, and a key component in flood reduction is the backwater walls and how the backwater walls should be maintained, are required to be maintained. So in terms of city-wide flood risk framework, it was developed in 2018, and it was developed as part of Stormwater Integrated Resource Plan. I will use the word SERP for that one. The city was divided into various sub-basins, and risk assessment was completed, and that how much flooding risk is in that particular basin. So it was ranked based on health and safety, environment, social, financial, and the basins which are in dark blue actually are higher risk, and as we go towards the lighter colors, they are lower risk. So that was the purpose of this one, was to identify where potential flooding could occur. As part of the SERP flood mitigation plans, various approaches were identified that included low impact development, flood proofing, maintenance, infiltration reduction, outfall gates, emergency response to all the way to dry ponds and trunk sewer separation. And as we look at it, is the more we move from this side, these are the low cost options, we end up into very high cost options on the other extreme. However, the focus of my presentation would be on the building flood proofing side of spectrum. So this is a small 30-second video. It will show you what causes property level flooding. So please, I'll play it and
the soil directly beside your foundation wall should be approximately 10 centimeters to 15 centimeters higher than the soil 1.5 meters away from the foundation.
So this slide actually showed us that the water needs to be moved away from the building. This is another one that on basement flooding, what causes property level flooding. So this is another short video. I hope you will enjoy it.
In a severe rainfall event, quite a bit of water can come off the roof. Under a typical 1,800 square foot home with a 900 square foot roof with 25 millimeters of rainfall, you can get as much as 2,000 liters of water being shed from the roof. That's enough to fill 10 standard size bathtubs. And that's why disconnecting the downspout can dramatically reduce the amount of water going directly into the sewer system.
So in this one, I guess what you may have noted is that they talk about 25 millimeter per hour rainfall event. Now that occurs roughly about every 5 years that occurs. But as my colleague Cincy mentioned earlier, when we talk about the climate change, this one would occur much more frequently. So if this occurs more frequently, it means more water going into sewers and potential for flood events.
In a severe...
The other causes of, one of the other causes of flood, property level flooding is infiltration. And this video will show you how that works.
The level of the basement floor, thereby allowing water into the basement via cracks in the foundation. Older homes are more at risk of infiltration flooding due to possible cracks in the foundation and also due to lack of foundation drains. It is more likely that homes built before World War II do not have foundation drains, while all new homes have them.
So I talked about 3 potential levels of flooding, how that occurs. One is rainfall, obviously, the other is surface flow, and third one is infiltration. So how they happen? So in a typical house, what we see is the red colored text actually shows you what are the risk factors. So one is ground surface. If the lot is poorly graded, the water is coming toward the building, obviously that is a risk factor. Other risk factors are that there are cracks in our manholes and loose joints. Pipes are cracked as the infrastructure is aging. There is a blocked weeping tile. There is clean out, which is uncapped. Floor has cracks, wall cracks, window well is not covered. So these are some of the major reasons that water would penetrate or enter into a building envelope. So how overland flooding works is, intense storm event, the storm sewer is overflowing now, the catch basins are overflowing, and if the property is graded, if the site is graded towards the building, water would flow towards the building and cause damage. It can go through the, through the backfill zone into the foundation drain. From the foundation drain, when they are connected to the sewer system, especially combined sewer system, actually, because the sewers are overflowing, they don't have enough capacity. It comes out and fills the basement. Infiltration flooding, that happens when the groundwater infiltrate into the building. So on top of the surface, there is no water, but groundwater saturates the footing drains. And from the footing drains is actually through the cracks and everything, it show up as moisture in the basement. This is sewer backup phenomena. So sewer backup occurs when there is a blockage within the sewer network. Unfortunately, we are increasingly seeing this phenomena, and one of the biggest contributor of that one is sanitary napkins, dental floss, that type of stuff. Now, when oil and grease from kitchen mix with that, it forms a kind of fat blobs. And they are, in modern terminology, we call it cancer of the sewer system. They are growing at phenomenal rate in the sewer system. There is a National Geographic documentary on this one also. It's called Sewer Blobs, and it's very terrifying to see what are these doing inside the pipes. So in that situation, we are increasingly, because all these non-disposable or non-decomposable wipes and stuff are increasingly in use, and their disposal in toilets is actually creating a lot of problems within the sanitary system. So that blocks the sanitary system. When the sanitary sewer is blocked, well, the sewage returns back to the building and comes out of the floor drains and unsealed, capped out. And the basement is unfortunately full of sewage, which is never a pleasant situation. So in order to reduce the flood risk, what is it that we should be doing or could be done? So there are a couple of things we do. Properly yard the grading. So, yard, make sure it is graded away from the property. Extend your downspout. Extend it some distance from your property. Put in a sump pump, like disconnect any the foot downspout, disconnect it, put it to the ground, and others that the weeping tile connected to a sump pump, put the sump pump up on the ground. Install a backwater valve, which is the most important piece of equipment, and a very simple equipment, but very effective equipment. Protect the window wells, put in a window cover on that one. So these are some of the major areas where by working on those ones, we can protect our properties and assets. So in terms of flood risk reduction, these are some of the common areas based on insurance claims where the flooding has occurred and how they are prevented. So one is install and maintain a backwater wall, the most important one. Extend downspouts and clean the eaves troughs. Floor drain is in your basement. Keep it clean and keep it clear. Some of the heavy users, the washing machine and stuff like that, you can install flood alarms. They are inexpensive alarms nowadays available. They are connected. You can monitor them through the internet. They're $30, $40 on Amazon or in big box stores. So those could be installed in the risk areas. One other is that the nearest storm drain. Here is one of the major issue is happening as climate change is happening. What we are seeing is hailstorm events. So hailstorm events happen. It breaks all the trees, the leaves and twigs. They all come in, block catch basin in no time. And what happens when water is not going to catch basin and you're living next to it, it will be coming onto your driveway or towards your property, because water keeps on pounding over there. So this is an important tool that we need to keep the storm drains clean. Grading around the foundation, installing window well and window covers, repairing. Another important thing is store valuables in watertight containers. If you have to store them in basement, like photographs and stuff like that, they are very difficult to recover after flood. So it is important to save them, to store them in watertight containers. And the third one, the final one that I would say, is sump pump. We need to regularly test sump pump, that it is indeed working when we need it. So this is about a quick video about backwater valve, how it works, and let me play it, please.
Device. It allows water from sinks, toilets, and tubs to flow out of your home and into the municipal sewer system, but has a simple gate which closes shut if water begins to back up from the city's pipes into your basement. Before installing a backwater valve, it is important to disconnect foundation drains and downspouts from the sanitary sewer. If left connected, you run the risk of flooding your own basement in the event of a heavy rainstorm that causes the city sewers to back up and close your backwater valve. The backwater valve.
This video is about the weeping tiles, that what they are and how they work.
Are pipes that run along the outside of the home's foundation. They are designed to collect rainwater and direct it away from the home, thereby preventing infiltration flooding to the property. One very effective flood reduction measure is to disconnect the weeping tile to prevent weeping tile drainage from going into the city sewer system. This is especially important if the home is serviced by a combined sewer, or if the weeping tiles are connected to your sanitary lateral. Weeping tile disconnection requires the installation of a sump pit and sump pump. The sump pump system is designed solely to manage foundation water and is not designed for any other purpose. The sump pit collects water taken from the foundation drains, and the actual sump pump will then pump that water outside of the home onto the surface of the lot, away from the foundation if done properly. If you are getting a backwater valve installed and have weeping tiles that are connected to the sanitary or combined sewer system in any way, they must be disconnected and directed towards the sump pit.
So far I talked about what causes flooding, what are the key factors that we could do to minimize the risk. I'll briefly go about the various kind of flood prevention program that EPCOR offers its customer. So we offer this flood prevention inspections, and that is no cost to Edmonton customers. Customers call us on the telephone number or email us, and our staff would then schedule an appointment for you with the flood prevention advisors. They come onto your property, inspect your property, identify the risk. We do external inspections and internal inspections. The internal inspections are suspended at this time due to this COVID pandemic concerns. So however, the inspectors offer this inspection through WhatsApp or FaceTime. We have those tools. So if you have those tools, you may be inside your property showing the backwater wall and the various things that the inspector would ask you. And this way, you will assess the risks that are the risk to flooding risk to the property, and accordingly will prepare a report for you, sit down with customers, and go through in detail with the report that what needs to be done and how it needs to be done. We are proposing now enhancing this program. We are trying to add 3 additional flood prevention advisors. Right now we have 3, so we are actually doubling the number of inspectors. We currently do historically about 400, 500 inspections used to be done per year. We are trying to push it up to 750 this year and the next year, and hopefully in future we look to reaching about 1,500 to 2,000 in the future. We also plan to offer inspections on weekends and evenings because we want the customer to be present on site that when the inspection is completed. And we look at about 80 potential risk areas on a normal residential property, that what are the potential risks and how to mitigate them. The other program that we have is a backwater wall subsidy program. If a property hasn't got a backwater wall, are built before 1989, or who had experienced basement flooding, are in the high-risk neighborhoods, we provide $800 subsidy towards installation of an interior or exterior backwater wall. And my colleague Roland would go through the what is backwater wall, how it is installed, and how it would be done. If you think that you need a backwater wall, please contact us on the telephone number that you see over there, or floodprevention@epcor.com. Customers need to seek approval, pre-approval for the subsidy. Once the pre-approval is granted, then you would work with the contractor of your choice, install it, submit the paperwork, and a subsidy will be paid. So from now onwards, I'll pass it on to my colleague Roland. He is our expert on backwater walls and associated stuff, and he would be pleased to explain this to you. So Roland, over to you, sir.
Thank you, Abdul. Thanks for the kind words. Yeah, so what you're seeing here basically is a backwater valve that is normally found in a home 2000 and newer. It is called the mainline full port, open port backwater valve. Full port, open port means that it has venting through it at the same time as it provides protection on the main sewer system. So as you can see on the top figure, that is a normal flow where anything that is flushed or drained in the home will travel over this flap that you see in orange at the bottom and go out towards the lateral, which is the sewer pipe that connects to the EPCOR sewer main under the street. The one on the bottom is actually showing you when there is a surcharge in the main. And what that means is when the EPCOR pipe is maxing out with a large volume of water from rain or snow melt, the flap has flotation devices on the sides, which you see in gray. They start to float and close the flap and protect your home from any sewer backup coming into the home. One tip that I can offer, if there is a large rain event like this and you're looking outside your street and you're seeing a good meter of water flowing past your home, that's a good indication that there's a lot of stress on the system and there's a lot of water. So if you are able, you can run downstairs, pop the access cover off this body of valve. It has a clear glass top on it, and look inside. If you see the flap that it's in a closed position, so if it's in a vertical position and you see water swirling on the right-hand side, that's a good indication that you shouldn't use any water in your home, because it's protecting from any water coming in, but at the same time, it's not allowing any water to drain out of your system. So keep that in mind, so that if you are, having to use a toilet or two, you're okay, but you don't want to discharge a washing machine or a dishwasher or running a bath or having a shower. And this is why EPCOR advertises a lot about water usage during major storm events. Next slide, please. I think Abdul, you'd have to, yeah, thank you. So this is a different type of valve. It is called an Fr4 Backwater Valve. On the left-hand side, you see it's in an open position. On the right-hand side, you see it as in a closed position. How does it work? It basically receives water that comes in and solids from the main, from left to right. And as it comes in, the ball that you see on the right-hand side becomes buoyant. The ball then pushes upwards and closes the gate to protect your home from any sewer backup. We like this. It's kind of a better way for us to protect your home, because the sewage never comes in contact with the flap, hence never really needing cleaning. The only thing that we do require, or that we do ask of you to do, is to inspect it regularly to make sure that everything looks in good order. So that's why you have the glass top on top, to be able to observe, as well as also be able to see when it is in a closed position, not to use any facilities in your home. Next slide, please. So this is the mainline backwater valve, which is the full port, open port. It is the one that's being introduced into newer homes. It's the same illustration as you saw at the beginning, but this is just a cutout to show you. As you can see, the yellow plate on the left on the bottom has a black looking foam piece. That's the area that receives water and will start to become buoyant and float upwards to close the valve. The cleanout that you see on top can be used for two reasons. One is to introduce a camera into your sewer to check the condition of your pipe. It's also used for putting in a snake so that your sewer line, your lateral going out to the municipal system, can be cleaned. Lots of issues like that are present with roots. Tree roots will grow into the joints of your clay tile pipe and cause you issues. That's where you would have a professional company or EBCOR come out and clean the roots in your pipe. It's also used for cleaning the valve itself, because as you can see, the flapper's on the bottom, so everything that is flushed will travel over this flapper. So that's why Abdul was saying restricting, flushing, feminine protection, condoms, dental floss, Q-tips, toothpicks. We see toys in these. We see all sorts of things. The flushable wipes aren't flushable. They don't decompose. Paper towels are challenging as well. So all these things, oils, fats, and grease, can get stuck on these flappers. So we always suggest, when you're frying food, wipe out your frying pan with a paper towel, throw it in the garbage, and then wash it out afterwards. Same with your salad bowl, because there's always oils and deposits in there. It'll eliminate the frequency of having to clean these devices, as well as your pipe and the municipal pipes as well, from having to be constantly flushed. So other than that, let's go on to the next slide, please. Yes, so this is called an adaptive valve. It was introduced about 10 to 15 years ago, because there is a product in the Edmonton area that was installed for a lateral pipe, and it is called Orangeburg No Corrode. And it is a tar paper rolled pipe that was introduced between the 40s and the 60s. And because of this, it was deemed to be used for 30 years. So if you do the math, the pipe has outlasted its lifetime. So therefore, right now, a lot of homes in older communities are starting to experience pipe collapsing. So at the same time as you're replacing your sewer pipe, these valves are being put in because of cost effectiveness. So these would be installed at the property line. So as you can see in the left picture, that is basically the pipe traveling out to the main at the bottom, and the valve is at the bottom. And then as you see, the riser pipe comes up to surface with a cap on it. So that cap is for cleaning, visualizing, checking, also being able to put in a cleaning tool if you had to. So what we recommend with this type of a system is once a year in the spring, before the major rains come, is to lower a garden hose through the cleanout at the top where the gentleman is standing and let it rinse away at the bottom that yellow flapper, because that yellow flapper also lays at the bottom of the valve. Therefore, everything that is flushed in the home will travel over this device and cause you problems as well. So the best thing you can do is once a year, like I said, in the spring, lower a garden hose to the bottom, turn it on for 5 minutes, rinse it off really well. The other reason for that cap is, as you see the gentleman on the left taking the whole device out, because if you're having your sewer cleaned with a snake or televised with a camera, those objects will damage this plastic yellow flapping device. So we recommend removing the whole stem, cleaning the system, doing whatever needs to be done, and then reinstalling it. One thing that we do mention to homeowners, don't be pulling this out thinking it's a 5-minute job, because you're looking down a black 8-foot pipe. The slots where this slides into is a 1/8 of an inch. So make sure that when you do take it out, that you have a little bit of time to put it back in, because it's like winning prizes at the exhibition sometimes. It's a bit challenging even for us to reinstall that. Next slide, please. Yeah, so this is a different method. It's really was used in the 80s and some of the 90s. It is a normally closed valve, therefore it can only go on a branch line, because the sewer system needs to breathe. Whenever it has a hiccup, it allows the air to flow through it and up through the vent system. So therefore, these devices were invented to put on a branch line. That's why the name is branch line backwater valve. So this would be like a main pipe coming into the basement, and then a pipe jogging off from the main to the bathroom to provide drainage for a sink, a toilet, a shower, a tub. So this valve would be installed in that pipe, because that does not require venting, therefore, that by code. So therefore, this is always closed, and when there is a backup, nothing can come back towards it, as you see in the right picture. And on the left picture, you see it open as the flow is going underneath it. So you also see these on a floor drain, just for a floor drain alone. But again, it is for a branch connection. It cannot be installed on a main. It will do the work, but by code, it's not allowed. So therefore, whenever a valve is installed, it is a modification to property. Therefore, a permit has to be pulled through the City of Edmonton plumbing branch. And then it needs to be, the permit needs to be closed. And in order to close it, an inspector has to come out and look at it. So, this will normally fail if it's installed in a main line. So therefore, check with the City of Edmonton, make sure you understand where the valves are going and how they're being installed. Your plumber should understand that a professional plumber should be hired to install these devices. Next slide, please. So this is a really, really basic backwater valve for protecting if you only have a floor drain in your basement. It is a very inexpensive device. You can pick this up at any hardware store or plumbing store. They're generally around $20 to $30. It does go in your floor drain, as you see on the left picture. At the top is the floor drain, and as you see where the arrow is, that is the cutout section where the product would be installed. Normally what it does, it allows water to travel downwards, as that cup on the bottom will drop as water comes in. If water tries to come back up from the sewer backup, that cup is pushed upwards and it plugs your floor drain. So it's really inexpensive protection. If you only have a floor drain, it is a good device to put in. The way you do it, you measure the inside diameter. You take this picture with you, or you Google this type of valve, which is called a flood guard. You can then go to Home Depot or any store you choose, pick one of these up, lower it into your floor drain about 2 inches, tighten the 4 screws on the top, and that will compress the 2 steel plates for that rubber to make a nice seal around your floor drain. We always recommend that you put a little note on your furnace or somewhere that you will be able to see when you installed it, because we generally see these at about 5 years, no longer working. The rubber decomposes, the copper tends to corrode and rust, and there's a little spring mechanism inside of it that does eventually fall off. It's very small. So, every 4 to 5 years, pick another one up, replace it. It's a very inexpensive way to protect yourself. Next slide, please.
So the next slide is about big backwater wall maintenance. This is an interesting video on YouTube, which shows us that even a backwater wall is not maintained, what happens?
The importance of backwater valve maintenance. Here we're going to take a look at a backwater valve that has not been maintained for over a year. So we're going to remove the actual access lid, and we could see that there's a lot of detritus built up around the valve. So at this point, we're going to put in a test plug to simulate a blockage or a overburdened sewer. Here we're flushing the toilet to simulate a backup, And as we can see, the flapper is not budging. So that's the yellow gate that would normally lift to isolate your home from the sewer. At this point, the water is flowing almost up above the lip of the valve, so we're going to remove the flapper. So this was a case where the flapper didn't work and the backwater valve was not working. At this point, we're going to do some simple maintenance with a regular toilet brush and some detergent to remove all the detritus and debris from all components of the valve. Now with the second test, we could see that the flapper is lifting. And if we wait, we'll see that with continuous flushing, that the water is backing up, but the flapper is closing. So this is a valve that would work. So it's very important to know that maintenance is extremely important if you want your valve to work and to protect your investment.
Yeah, so what this demonstrates is a backwater valve being clean and how it should be cleaned. The only comment that I will make is do not remove the cover from the top, as these screws are torqued at the factory at a certain pressure, because we found some homeowners removing these and then retorquing it and cracking the plastic and then having leakages through the top cover. So that's why it has a clean out at the very top, the black cap that you would unthread with the O-ring, and you would reach inside. You know, we say usually get a coat hanger to activate that flapper. Once you've activated, take a toilet brush or a paintbrush, pick one up at the dollar store, clean it really well like you saw in the video, and then run a bathtub of water, say about a quarter up, and then release it. That pressure of water will wash all the debris that's inside the area that you've cleaned, and then you can replace the cap with the O-ring back onto the valve, tighten it so that you don't have any sewer odors or water coming back through there. And once you've done that, you know, every 6 months, we recommend every 6 months, but you be the judge. It depends on what you use and what you flush. The manufacturer says to clean it once a year or as often as possible. So we've done testing on these devices, and we find that the majority, usually about 6 to 7 months, it becomes a problem. So we do recommend 6 months, but again, you're the person using it. You need to judge how much cleaning it requires.
Thank you very much, Roland. So that brings our presentation to the end, and I hope that you know, it is we have answered your questions. If there are any questions, we are here to respond to them. Thank you.
Thank you again to today's presenters, Cincy Modale, our guest presenters from EPCOR, Abdul Khan and Roland Newman, for sharing your time and your expertise with us, and also for answering and responding to those questions that have come in from the audience during today's webinar. Thank you, Karen Young, for handling all of the logistical pieces to make this happen. And our audience, thank you. And I hope that we'll see you again at an upcoming session. Visit changeforclimate.ca/lunchbox series and have a terrific afternoon.